Mitch is going to talk about Lungu-Software Is Data Too. He's from the land from Anna. But he looks like an actor. The actor?
Thank you.
Okay, that was the presentation.
Thank you, Hernan. Hey guys, can you hear me? Okay, you can hear me like this? Is this better? Oh, this is better. Okay, cool. So, hi everybody. My name is Mircea Lungu, and I currently work at the software composition group where Gabi did her PhD. Greetings from Bern, Gabi. And this is Switzerland, and the talk that I'll give today, it's inspired by work that I did at the University of Lugano. This is the sunny part of Switzerland, and the University of Bern, which is the mountain part of Switzerland. When Gabi invited me, I asked Oscar, my boss, how to do a keynote talk. I never did a keynote talk before. And he said, well, it's easy. You just need to be inspiring and informative and, like push your own work and be controversial. And I said, hey. So I decided I'll drop all those things and try to talk about some of the things that I know about. And some of the things I know about are writing software, and I do some research in software engineering. So I thought, okay, I'll try to provide you with a perspective on how can we look at software. And there's a story of 5 blind men talking about how's an elephant. And they eventually couldn't agree, so they went to experiment one. And one of them touched the tail of the elephant and said, it's like a rope. And another guy said, no, it's like a tree trunk. And the other guy said, no, it's more like a spear, because he was touching the tusks of the elephant. And the fourth one was like, it's more like a house for me. And, it's always different people can have different perspectives on things. And during my work on software analysis, the perspective that I often took was other people's source code was my data. We normally take we make a separation between, the source code is the program that we write, and the data is it's what the program works on. And, the program lives in the ID and the data in the database. And, during my work, it wasn't like that. Now, after I proposed the title and after I started working on the presentation, I figured out this is not new for Smalltalk people. I mean, in our image, we have objects, and our objects are our code, and our objects are our data, and all lives together. So, in a way, this is not going to be new for you. But it's just, my goal is to show you that if we take this perspective, we can do cool stuff. And there's also the other perspective of 5 blind elephants talking about how people are. And then they decided to experiment it. And the first elephant, they went to the forest, they found a man, or went to the village, found a man. And the first elephant felt the man, and he said, men are flat. So the other ones agreed with him after. So every perspective has also an opposite perspective. And Hernan was saying next time I should give a talk on data is source code too, maybe. Source code is data that has several properties. First is textual, and that means we write it so other people can read it. We normally think about, you write it for the machine, and I'll say, no, you write it so other people can read it. It's large, and it's actually too large for people to read it. And this is why we need analysis tools to help us keep an eye on what's the big picture in our data. And we can learn from data analysis, and we can learn from, when people handle large amounts of data, they often use information visualization, and we can use information visualization on software data too, and I guess the community knows about that already. And it's data that's evolving. And like if you think about this, it means you want to keep track of how your data evolves. You want to keep track of how your source code evolves. And if you think about, again, data as in data in your database, as it evolves, the data changes, but there are some constraints that always hold. Like, you've got your database schema, and your data always fits in that schema. And sometimes the schema evolves too. And I think we should, we have to think about how to keep, our softwares, what are the constraints in our software, and how do we ensure that as our software evolves, the constraints still stay. And finally, it's big data. We were talking about buzzwords earlier, and I think big data is a big buzzword. And if you want to learn more about it, there is this big data Borat on Twitter that's worth following. It's a funny account. And so these are the 4 parts of my talk, and I'll try to show you some, kind of some of the thoughts I had with respect to this thing, some of the work I've been doing, some of the work other people that are, part of my software engineering research community have been doing in these directions. So, software is textual data. And what I'll argue is that we should be writing first for people and then second for the machine. And I guess in my defense is the fact that some of the best companies that are out there, that are employing some of the best people that are out there, enforce this. And what do I mean by this is I have one of my good friends and colleagues, and one of the best programmers and hackers I know is working for one of these big search engine companies. And he came to me frustrated, like every time I want to push code, it has to be reviewed by 2 other people, and if they don't get it, it doesn't get pushed. So basically, first people have to read it, and only later does it get compiled and run as a service. So this is literally the software. It's first read by people, and then by the machine. So if we think about, okay, can we learn, what can we learn from people that are into this business of writing to communicate to other people? And this is the business of writers. And Stephen King, he said this thing at some point, telepathy is not as cool as writing. Telepathy is this thing where you can put your thoughts in somebody else's mind at a distance, right? But he was saying, well, writing, I do the same thing, also that it spans both space and time, because you'll be reading my stuff long after I'm dead. So telepathy is weaker than writing. And if you think about writing is ambiguous. Writing, it's not as cool as source code. Source code, you can put your thought in somebody else's mind, and it's unambiguous, right? So that's actually even cooler. So next time somebody's asking you, hey, what's your job? If you could say, I'm a writer. I'm more than a writer. So what do we, sorry? Stephen King has this book on writing. I don't particularly read too many of his books, but I read this one. And he has advice for people that want to be writers. And one of the advice, it's a big book, and I won't go through the details, but he says, if you want to be a writer, there are 2 things that you have to do: to read a lot and to write a lot. And I think this is the same for software. And I think that sometimes, looking at myself, I mostly write, I don't read enough. And I guess that's actually a good thing to do. If you can make time and do some reading every now and then, and see, you can't be a good writer if you're not reading. And then if you want to know how to write, there's Strunk and White. I see Gabi nodding, and I guess that's one thing, that it's a book. It's a small book, but it's awesome book. And if you want to know how to write in English, you have to read it. And one of the principles that Strunk and White propose there, it's omit needless words. And I think it's beautiful because it's 3 words. You can't make it shorter to communicate the same thing. And it's a principle that explains itself. And they have another one, which is make every word tell. And I think we should take this and apply it to software too. Basically, I keep telling often my students that we don't get to write that many algorithms when we program. You know, we work in a company. Who wrote a balance tree in the last year? Nice. So it's not that nobody writes them, but probably you write them in the lecture, and it's not very often. But what you do every day, and for most of the time, it's put names on things. You put names on classes, you put names on methods, and that's actually where your creativity can be channeled, and that's where, you know, every word can it's important to think about, you know, your class name and your method name and think, well, and you know, I always said this, but it's always feeling like, well, who am I to say that? It's not even like I always do that with my own code. And then it was really cool to find this on Stefan Wolfram's blog. He says the most important activity in the development of Mathematica is naming functions. And he goes on, it's an interesting blog entry, if you Google for it, you're going to find it. He goes on to talk about how for defining the name of a function, they might have a meeting, and that meeting would go for half an hour until they're like, this really expresses what we want. Now, I guess that's what we should strive for. I hear, you know, not everybody has the luxury of working in a, you know, in a place where this is possible. But if you can, I think it's worth doing it. Oh yeah, that's, so after this, I thought, okay, I saw this movie on the website of JetBrains. JetBrains is a company, they hire smart people and they work on this MPS system, meta-programming system. They call it a language workbench where you can, like you can allow people it's a system that allows you to modify your language. And they have this, you know, it's a 16 minutes video for how to add the unless keyword to a Java-like language. And it's cool. You know, it's a very slight distinction between if and unless. You know, if it's not raining, I go to the beach. I go to the beach unless it's raining. So it's like a negation of an if, right? And still, we use it sometimes, and sometimes we don't. So it's just sometimes using unless makes your intention just a tiny little bit clearer. And I think, you know, it's worth going that little effort to make your code more clear. I guess in Smalltalk, probably you're smiling in your mind because you can just write 2 lines of code and you have unless, and you don't need a company and you don't need a lot of smart people to empower you, or they were smart, you know, they were there. And you can just do it, right? So I was actually, after seeing that video, I was like, I know the piece of code I'm working on right now could use a bit of unless, and I went and I redefined it with unless, and I'm going to show it to you a little bit later. This is a trend it's just a very tiny trend in software engineering research, where people are going and trying to do studies with people and try to understand what people, how do people understand better software. And this is a paper by Laurie and his colleagues, which shows that better comprehension is achieved when full word identifiers are used rather than single letter identifiers. You know, they took 100 people, they did a study with them, and they came up with this conclusion. Now, I think that's awesome that we are doing this kind of studies. I think every time you see this study, you always have to ask questions. Like in this particular case, they are looking at, the source code they're looking at were algorithms. And they also figured out that actually for advanced users, it doesn't matter that much. For the beginners, it's important to have full identifiers. For advanced, it doesn't. So you always have to kind of try to see the bigger picture of the study. And after seeing this, and after the Faro sprint 2 days ago, I thought about some of the identifiers in my Smalltalk image, and they are, you know, this is it's a sentence, but some of them are like stories, right? And I was thinking, if anyway we have these sentences, I'd love to, as a small usability increment, it would be cool to be able to, when I Smalltalk, I use sentences. And when I read a book, I use sentences. So can't I just hack my VisualWorks image to show sentences? And it turns out with a few little hacks, you can actually make your source code look like this. And that's how my code now with unless and with sentences looks like. So, get URL from user or return self, extract project name from the URL, and then notify cloning it while executing this thing in this directory, unless the repo is already cloned, case in which you don't do anything, right? So this is a very small, it's a hack, and I won't tell you how I did it. Just try to guess. If you're really curious, come and we can talk at the end. So basically, this incurs a little bit. Any code can be run like this with a bit of refactoring and with 2 extended classes in your image, basically. And what's nice about this is that you can imagine that now your tests, instead of being, the test name is not an identifier anymore, but it could actually be, one of the rules in your system, one of the rules that your system can obey. I mean, if I talk about language, hacks and extensions actually in improvements, I must mention Helvetia, and I think you've seen Lucas Rengli last year, and he talked about, and that's the cool stuff. This was just a little, idea, an afternoon's play. Inform 7 was, it's one of the projects that does something like this. It's a domain-specific language for adventure games, the games where you walk around and you talk to people. And they managed to have a DSL, which the first time you read the program, you think it's the story. And only later you realize there are actually rules that are governing. It's a structured language, but at the first sight, it looks like a story. And I thought that was awesome, and it was a bit the inspiration of the previous hack. So to conclude, I think we need to think usability also when we write source code. Usability is very important. We saw this with Apple. Most of their products were successful because they have awesome design. And I think when we have the field of web usability, and we know when we have principles of how to implement good websites. But often, the website, we write it and we give it to the customer, and that's why it has to have usability. But often the API that we write it and we give it to the next programmer, and we should respect him too, and this thing should also have usability, and we should have usability in mind when we write code. I think to wrap up this one, software is large data, and War and Peace, one of my colleagues just did a quick estimation. It has 60,000 lines of text. Anybody read this one? I shouldn't read. Awesome. The Argo UML code has 90,000 lines of code. So, it's hard to read this one. It's impossible to read the Argo UML code. And if you want to get a picture of what's in that system, you need tools for that. And I guess most of you will have seen tools already for that. The Moose analysis platform, it's a platform for analyzing object-oriented systems. And if you know Tudor, one of the main maintainers at the moment, he keeps saying that this is not a software analysis platform, it's a data analysis platform, because actually it works on a meta model which is independent of software. And it's again this treating software as data, data as software. At some level, they are all the same. One important tool in the toolbox of the software analyst is visualization tools. And I think we've had awesome tools in Smalltalk. CodeCrawler, it was developed by my advisor, Michele Lanza, and one day he came back to the office and said, at the last presentation I gave, I killed CodeCrawler. And he said, it's over, it's history, and it's time to move on. So after that, things that came after were Mondrian, Software Note was one of the tools I was working on, and Roasal, we are going to have a demo about it later today or tomorrow by Alex, and that's cool stuff. I know a little bit more about this one, and I want to show you some things that you can do with it. I was planning on a demo, but I wonder if there's enough time, or I can push the demo. Okay, I could also push the demo for tomorrow because I have another quick talk tomorrow. So let's do it like this. I'll show you some pictures. If at the end of the talk there's still more time, we could do the demo. Otherwise, we do the demo tomorrow. So there's more material for the talk of tomorrow. So the idea in Software Note is to try to show dependencies at the high level in a software system. What we have here is the Lucene, Apache Lucene. It's a search software, search engine, and what I see here are the main modules. What I see here is the package tree, the Java packages. And the packages which are highlighted in green down here, I can see them up there. And I see dependencies between them, and it's the classical, the bigger a package, the more lines of code that are inside it. And what you can see also, like you can see all the way down to the class level, and I have highlighted, with green I have highlighted tests, and with orange, and the mapping from light orange to dark orange, I had mapped the fan out of every class. How many other classes does the class use? And what you can see here, for example, is that there's this big class here in the query parser that's like it's controlling a lot of the behavior in the system. You can also see, well, they have tests spread all around the system. You can see they have, mutual dependencies. It's not a very layered architecture. I mean, I have my search depends on the index. Well, yeah, that makes sense. My index depends on the search. I guess it makes a little bit less sense. And we could go and inspect that dependency. And if we go and select the dependency, we can, well, first see that there's a bunch of classes here, the ones that are highlighted with yellow, that are using basically two classes there. So this cyclic dependency could actually be broken. And I don't know anything about that. I don't even fully understand the domain of this software. I never used it. But after a little bit of playing with it, I can probably propose a refactoring of the structure. Okay, what's this? Oh, this is Argo UML, and I'm showing, in some other cases, I have another mutual dependency between UML and UI, but this one is going to be harder to break because there's more classes that are invoked there, and it's not going to be so easy. So the way Software Note works, it takes as input a FAMIX model, and it builds out of it a hierarchical graph. A hierarchical graph is this data structure, which is quite cool in my opinion, where you have a graph, like a planar graph, and then all those elements in the graph can be aggregated in a tree. So then that allows you to navigate and section the graph at various levels and see different perspectives. You could look at the highest level dependencies, or you can go all the way down to the lowest level dependencies. And on top of that, we have some visualizations. Some of them are this space filling variation of tree maps that I showed you, and on top of that, it's all the interaction with the view. I mean, you need to be able to filter dependencies, because one thing which you soon discover is that the lower you go in the structure of a software system, the bigger the mess is. I mean, if you think these are many dependencies, you should go a few layers lower. It's a lot. So there's various interaction mechanisms. Usually, I would argue that we take tools from data analysis and we apply them on software. In this case, we did it the other way around. We took this tool, and this is the work of Dennis Shank, one of my students, who actually is working on decoupling, and on first he's porting the tool from VisualWorks to Faro, and in the process he's decoupling. When I implemented it, it's quite tied to the model of software, so you can't really use it to analyze anything else without refactoring. And it was good like that because I learned a lot, but now we are trying to do it in an model independent manner, and that's what Dennis is doing. And as a proof of concept, he applied the same principles on the data from a Stack Exchange website. I guess you know Stack Overflow. Stack Exchange is this, it's a forum where every user has a reputation, and everybody answers questions, or by answering questions or by asking a good question, people can vote, and then your reputation goes up. And people use it a lot. I think it's fascinating how for this, I think we are wired to like, numbers that are increasing. I think it's the same principle between, like in your bank account, like in your Stack Overflow reputation, like in Farmville. You see a number going up, and it's awesome. And so, you have the reputation, and then you have information flowing between users. And then we said, can we see if we aggregate these users geographically, up to the country level and up to the region level, up to the continent, can we see, data flow between continents? And first, this is the way reputation is distributed, a lot of it in Europe, North America. The other continents are not doing that much, but remember, this is on Travel Stack Exchange, so this is not on the Stack Overflow. I have the intuition that Stack Overflow would look a little bit different, but Dennis didn't do that yet. And then this is how the information flows. You see there's a lot of information that flows from Europe to unknown lands. Not everybody does specify his belonging. If you think about South America, we don't see it here, but it provides more information to North America than to Europe, for example. And you can learn more about these things. The point here is it's a general data structure that we can apply on software or on other types of data, and it helps us to get the big picture. And then from here on, you can drill in and learn more about the details. That's it. I guess one thing which would be interesting would be how can we, it would be good to have this thing in the cloud, because now it doesn't make sense that thinking in the context of software, I run the same analysis on my machine, and Gabi on the same version of the system runs the same analysis on her machine. And at the moment, there's just a little bit of work that we are doing towards making this thing more collaborative, because a software version, it's frozen in time. You only have one version of Azurius 4.1, so it doesn't make sense that we repeat the analysis. It never makes sense that the same analysis is repeated twice, and this is the same in the context of the same company, I guess, too. Okay, source code is evolving data. This is a graph of some of the systems in the GNOME family of systems, and you can see this is the size as measured in number of files. Every color represents one project, and these are, I stacked all of them together so you can see that it's just a monotonically increasing graph. Software by default just grows. At some point it might stop, and in very exceptional cases it kind of decreases a little bit. You can make a dent in it, but most of the time it just goes up, just goes up. And the problem there is, can we keep up with what's in there? In this particular case here, I guess it was easier to keep up when you had a few tens of files. Here, when you had 50,000, it became harder. This is work by Gerba and his colleagues, and it shows another case study where every line is a file in the system, and the colors represent developers, and horizontally you see time. So what you see here is that basically over time, the green developer is replaced by the blue one, who touches all the code, but later the green developer comes back again, and then the red developer has sporadic contributions. And this is useful, and this gives you a feeling of what was happening in that system. With one thing which you don't know, it's in this particular case, it's not easy to see how did the various events in how the system grew over time. And with my colleague Lily Hattori, we thought, okay, what would be if we recorded and replayed all the development sessions? Would it be useful? And to do that, we implemented this little plugin in Eclipse, which would record every small developer interactions and publish them on a server, so then different members of the development team could replay their own development sessions or other people's development sessions. And this was not a video replay, it was just replaying the changes at the AST level. And because it's a trend again that people are trying to do more controlled experiments and doing more scientific work. So it used to be that I think 10 years ago, if you build a cool tool, that would be a piece of work that could be publishable. Nowadays, you need to build a cool tool, and you need to do a controlled experiment to show that it's useful. And I think there are pros and cons for this. We did a controlled experiment, and we figured out that for some tests that we give the users, their answers would improve correctness, or using the tool would improve correctness, and they would also answer a little bit faster. I think that's not important. What I think much more important for me was the fact that as we are working on this tool, we would meet every Monday to do pair programming. And from a Monday to the other, you always kind of lose track of what you're doing and always kind of trying to, what exactly was that we were working on? So at some point, the tool started working, and then we could replay what we did last Monday. And that was like, oh, right, yeah, it's that what we spent a lot of time with. And actually, I think for me, the most valuable thing was that this was useful for us, and these results are not interesting. Unfortunately, Lily is now not doing research anymore, and I don't think the plugin is maintained anymore. But in my opinion, that is a useful approach. And I don't know where is this going. I don't know if we will eventually record all these things. There are challenges. How do you, you end up with a lot of information. How do you navigate it? And there's a lot of research possibilities there. But I think this is one interesting direction. The other thing that I mentioned was we want to constrain our evolving data. Our evolving data in the database always must fit our schema and our checks before it goes to the database. And I think the source code is the same. And our one schema is obviously your programming language, and it needs to compile, and that's cool. But I think that there's always, there can be a little bit more that based on the situation, you might have more constraints, or you might want to have more constraints. And for example, there is this work of Knodel on live compliance checking, where they did a controlled experiment again with 2 teams of master students. And the students one of the groups was given a system which would check some architectural constraints. And basically they had, I think in their case, they had, this class can't call this layer can't call the other layer, and something simple as this. And what they discovered was, after a period of development, the guys that had the constraints in place and could not check in when the code was violating the constraints ended up with better structured software than the other ones. And I think it's interesting here, and one of my colleagues is working on this actually, Andrea Caracciolo, that just started his PhD in Bern, is what do people actually want to express? What kind of constraints do people have in their systems? And first, after we find out what are these constraints, can we come up with a way of addressing the most critical ones, the most, for example, I was there at an interview that Andrea was doing with one developer, and it came out that in their system, it was always when you had to make a change in this class. You also had to remember to make a change in the other class and make a change in some other file. And this is knowledge that's in the head of the guy that does it, but it's not easily passed down to the others maybe. And even if it is documented, it would be nice if it were something like a test case maybe, so you could constantly run it and be reminded sooner about it. So this is, I think there's, oh yeah, if you have feedback on what are some of the constraints that you have in your system, talk to this guy, he would be curious to learn more about it. And finally, software is big data. And it's some years now since there's more and more software that's been published online in large repositories like SourceForge and GitHub and QuickSource. And there's knowledge that's encoded there that we don't fully use. I mean, you know, you might have search and that's cool, but there can be more than that. And I think one challenge for the future development tools and IDEs is how to tap into this information that's already there, that we could use probably to learn to write faster the code, or maybe find mistakes in our code, or maybe validate some hypotheses that we have and that require empirical validation. So there's two levels at which you can look at these large amounts of, if you think about QuickSource, because we are probably using, many of us are using QuickSource. At one level, it's a system which has many systems that depend on each other. And on the other level, it's just a sea of source code. If I look at the method level, it's just a lot of methods in there. Or I can look at the level of systems, and you know, you have this seaside thing that everybody depends on, and many people, you know, copy and paste in their repository. So there's two levels at which you can look at this big software data. On one hand is the systems of systems, and the other hand is just a sea of data. I'll try to talk more tomorrow about this systems of systems perspective, the software ecosystems work. I'll just try to give you a quick idea of what cool things we can do if we look at, you know, all this source code as a sea of data. Oh yeah, and that's one of the most awesome mountains that you can hike in Romania. I was there 2 months ago, and it's normally what people do is you go up, you sleep somewhere there, and the next day you come down. And we were with a group of people, and the organizers were overly optimistic, so we did it all in one day. And what happened was that towards the evening, everybody was very tired, and we still had a lot of work to do. And I was encouraging one friend that was really on the edge of, you know, not being able to do it anymore. I said, hey, you can always make another step. And then my friend said, you know, you said it so beautifully. Yeah, you can always make another step. And I do think that is like that. I did some endurance sports, and you can always push yourself just a little bit more. And I think that's cool. But I went home after that, and encouraged by, you know, my friend's appreciation of my sentence, I was wondering, did anybody ever say that before? And I Googled for it. And actually it turns out that many people said it before, and most of them said it like this: you can always take another step. This is the correct English, or it's like more appropriate English. So the lesson here is, first, you can always make another step, take another step. And second, your utterances are not as unique as you think. And if this amazing moment couldn't make me say something unique, I guess it's the same with the source code that we write. It's not that unique up to a certain level. So the question there is, can we use this information in the source code repositories to discover, to use, you know, use this fact of their can we use this similarity between the source code that other people have already written and to the source code that we are writing now? So the challenge here is how can we learn from instances of similar problems. I don't know exactly how, but there's some hints on which directions could be useful. We could learn from Amazon, right? I mean, Amazon saw that I looked at this book and said, you know, you might want to read this one. By the way, these two are awesome. Fire Upon the Deep and The Deepness in the Sky. If you like science fiction, they are good. And they are written by a computer scientist, Finch. So can we do the same with software? And some people do it already. So there's this work of, not of Schaeffer, this is work of Lifshitz, I think, somebody else, who was looking at commits to the versioning system and observing that, you know, always add listener occurs together with remove listener. And when sometimes add listener is committed without remove listener, there's like a quick commit after that, which actually adds remove listener. So that's kind of a hint of probably these things always go well together. This is the work of Schaeffer that was saying, well, if we look at the way people are using this library over time, we see that very often calls to plugin shutdown are replaced to calls to plugin stop. So it might be that, you know, in the newest version, this is what people are supposed to be doing. In our work, we were looking at, we started to do something along these lines, and the first thing that we did was to see, okay, let's look at Squeak source and let's see how much people do actually just duplicate the code in there. And somewhere between 14 and 17% of all the methods in Squeak source are duplicated, as you know, the study of my colleague Schwartz and ourselves shows. This is, on one hand, people used to think that, you know, code duplication is bad. The empirical studies, because the idea was, you know, you copy the code in many places and then you update one instance and you forget to update the other ones, and that's going to bring bugs. I think one nice thing about doing this kind of big data analysis was that people were looking at actually the evolution of multiple software systems, and they tried to figure out, does this actually introduce bugs? And it turns out that cloning doesn't introduce so much bugs, so it's not such a big problem. In fact, after talking with Dale one of the previous days, we were thinking that's actually nice, that you have 17% of the code that's duplicated. It means people are reusing. I mean, maybe it's not the best way of reusing code, but it means that somebody thought it was worth taking this piece of code from here and copying it. It might give us an idea of what do we want to, how to encourage maybe a better way of reusing. But, you know, it's not good, it's not bad in itself, I guess. I guess this is what I was talking about. We can use the large amounts of data that we have to try to validate claims based on analyzing large amounts of data. I know, you know, this is one of the works that I mentioned. I think Oscar Kalau did some work on studying how do people use reflection. If I remember correctly, it was like how do people use reflection in Java versus Smalltalk. And the results were interesting, showing that actually we don't use so much reflection, or we use only a few features of reflection. He might be talking tomorrow about it, so I don't want to go too much into the details of that. There's a trend towards moving. We should be using less inheritance. We should use more composition. We could try to see. It would be, I think, all this software engineering has a lot of people that are proposing things without too much backing up. You know, in the pharmaceutical domain, you have to have a lot of controlled studies and before you can push a new drug. In software engineering, it's enough if you have a very persuasive personality. And I think that's cool. I think that makes it more interesting. But it could be also nice if we could be trying to propose things which are more verified, or try to support our claims with empirical data. So to wrap up, I think source code is data too, and it's 4 types of data. it's textual, and if we remember that, we will think about the fact that we want to communicate information with it, and we'll pay attention to every word we write. It's evolving, so it's good to track it. It's good to make sure that it keeps the rules of your system, and it would be nice if we had a better way of communicating these rules in a more executable way. It's large, so it's good to have analysis tools for it, and it's big data. And if we learn how to tap into this big data, we might learn how to make better choices when we write code and when we build maybe our next ID. I think that was my small perspective that I wanted to try to see if it kind of stays together. I still think that the title was not the most inspired, but I think that the ideas, there's something that we have to consider in the next tools that we build and in the next programs that we write. Thanks for staying around until the end, and yeah, I think.
You started 5 minutes later, so we have 15 minutes. So I don't know if you want to do the demo or you want to do the questions.
I think I'd rather do the questions and we do the demo tomorrow and we don't keep people from lunch.
What will be the future of software analysis? So what do you want this to be more, and is there anything that we're going to do in the future that we can do now?
Okay, so if you ask me, I think if you ask different people, it's a bit like here. If you ask, for example, my friend Doru, he will say it's a lot about people writing their own tools and just empowering people to write their own custom analysis tools. And I think there's a lot of wisdom into that. And on the other hand, I think that as when you're a researcher in software analysis, you should work also on concrete instances of problems. Basically, if I think back at the code, what was that? Code crawler. And this is like kind of the prehistory of software analysis. It used to be that you could customize all kinds of metrics on showing on those polymetric maps. But there were a few views that Lanza thought these were actually useful. And I think the future will be like this on this aspect. On one hand, we are going to provide a set of, we know these are useful things that you guys want to look at. And on the second hand, we will provide, actually, if there's something else you want to look at, it's easy to analyze this too. So it's not going to be just, it's not going to be as open as just, a programming language. It's not going to be as closed as your iPod. It's going to be, somewhere in between. It's going to have the power of customization and is going to have some hard-coded solutions in. I think the other thing which is complementary to this, it has to be collaborative. And most of the things we are doing now are not even touching that. We have visualization tools, we have static analysis tools, but we are not thinking that much about the collaboration aspect. And I think that one is important.
Yes.
That's a good question, and I think like people that work on clones, they define 3 types of clones. There's type 1, type 2, and type 3. And type 1 is literal, it's just copy paste. Type 2 is what your students are doing, copy paste with variable rename. So the system doesn't realize that it was a clone. And type 3 are copy paste with maybe some more changes. And the way we do type 1 we just do text matching. For type 2 and type 3 we do a little bit more interesting algorithms for detecting them. For example, for type 3 we have this shingles algorithm where you're taking sets of tokens, you're hashing for each set of tokens. You have a window that goes through your method. You're creating hashes out of every k tokens, and then you're dropping some of the hashes to introduce a little bit of imprecision. And basically that turns out to, although it sounds quite open, it turns out that that's the 3% difference basically. So it's not overly overreaching. So, but I might bring it up more tomorrow if I have time and go into the details of this. But basically, 14 to 17%, 14 are the exact clones, and 17 are more relaxed definitions of clones where you could have slight variations inside them.
This is for both cells?
Yeah. Yeah.
But maybe the trait will remove with part that issue. Because sometimes it's not that you just copy and paste because you didn't come with the right design, but you have the same trait in 2 different parts of the system. Unless you use traits, you have to code.
Yeah. I think there's something to that, and probably what we should consider more is the fact that people don't necessarily, I say method level, but I don't think anybody really copies a method, right? Maybe as you're saying, you want like a trait, or I think very often when I looked at it, it happened that actually entire projects were copied, or a few classes, which could be, again, and it would be nice if there was a better approach than duplicating 5 classes, but there's something to say about that too, they're under your control, nobody changes them, although, if you can link to a previous version of the system, that also should never change theoretically. Practically, maybe somebody decides that he wants to remove a package, and then you don't have them. So actually, at the moment, it's probably a sane strategy to just take it and put it in your repository. But if there was probably a better infrastructure, we would see less, I guess.
Most of the analysis you have given were based on the static structure of the code and what were dynamic equations. So it's something that you try to work on, so we require that sort of work on representing the dependencies between objects.
That's cool. Actually, for most of for the little research I was doing, I was mostly looking at static. I always looked up at people that did dynamic analysis. I think it's cool. I think it's very interesting. You're looking at the live system, and I think the two need to complement each other. I had a student that was working a little bit on trying to put the two analyses together in a particular scenario of trying to detect irrelevant code, dead code, and there turns out that dynamic analysis can be quite useful. The work is not finished, but I think dynamic analysis eventually, you care about the performance, you care about your memory, you care about the code that actually runs, and I think that's very important. I guess I'd like to do more of that in the future.